In this video, a 23-year-old Caucasian female presents from an acute attack of multiple sclerosis. Impulse transmission along the left optic nerve is impaired. So let's draw our left optic nerve. So let's say this is the right eye and this is the left eye. Okay, and it says that the impulse transmission along the left optic nerve is hindered by an area of demyelination. So let's see, where does optic nerve takes its impulse. Now from the left side, the optic nerve is going to take its impulse all the way to the pretectal nucleus. The pretectal nucleus like so. Just like the left side brings the impulse to the pretectal nucleus on this side, the impulse from the right side is also brought to the pretectal nucleus like so. Okay? From here onwards, though, the pretectal nucleus is going to make two synapses. Okay? It's going to make two synapses with something called the Edinger-Westphal nucleus. The Edinger-Westphal nucleus are kind of here. These are the nucleuses for cranial nerve 3. So two impulse goes. One, actually I want to make this a different color so that we can distinguish. So one goes to the one on the side of the on the right side. So one is going to go from here to here. The other is also going to go from the right side to the left side. Okay, it's going to make an impulse here. Now from the Edinger-Westphal nucleus, by the way, this is pretectal nucleus, this is the Edinger-Westphal nucleus. So from here, the impulses are going to be carried to the front of the eye where the oculomotor muscles are. So from here onwards, one of them is going to go to the front of the eye, to the oculomotor muscles, and from this one, the oculomotor nerve goes to also the left side front of the eye to the oculomotor muscles. And both of these passes through a ganglion called the ciliary ganglion. Now that we have a normal anatomy of how the pupillary light reflex, by the way, this is the pupillary light reflex, and the pupillary light reflex is always through two cranial nerves, first with 2 and then with 3. Okay, so in this pupillary light reflex, now we will see what happens with the question. The question says that impulse transmission along the left optic nerve is hindered. So which is the optic nerve? This blue region is the optic nerve. So this is what's hindered. Okay, if this is what's hindered, then what's going to happen? The impulse going to the different Edinger-Westphal nucleus is also going to be hindered. So let me draw that just so that we can cross it out like so. So one is going to go here, the other is going to go here. Okay, so both of them is going to be disrupted like so. So this is going to be disrupted and this is going to be disrupted. Okay, so this is the situation, because if one is damaged, the other is not just going to get the information from the optic nerve. The Edinger-Westphal nucleus is not going to get the information from the optic nerve. So this is the situation we are in. So now they're saying that if we shine a light, now we're shining a light on both the eye. First of all, light in the right eye. Okay, so here we are shining the light on the right eye. What's going to happen to the right pupil and the left pupil? So the right pupil is going to constrict because there's too much light. So the right pupil is going to constrict. Okay, because there is no problem with any kind of demyelination. Now this impulse is carried by the optic nerve, and from the pretectal ganglion, the information is carried to the Edinger-Westphal nucleus, no problem, right? See, there's no demyelination here, no demyelination here, and from both these, this is going to go back to the right side and to the left side. Okay, no problem. So what's going to happen to the left side? The left side eye is also going to constrict even though the light is on the right side. So I can say that this is also going to constrict. And this happens when there is light in the right eye. Light in the right eye. Okay, so what if there is light on the left eye? So here I am putting light on the left eye. If we put light on the left eye, the information will not be carried to the pretectal nucleus. So nothing is coming here. From the pretectal nucleus, no information is going to go to the Edinger-Westphal nucleus. As a result, Edinger-Westphal nucleus is not going to be able to carry the information from here through the oculomotor nerve to the oculomotor muscles. So this eye is going to remain vasodilated, or there's not going to be any significant change. So there's not going to be any significant change here. There's not going to be any significant change there as well. So these two are going to have no change. On this one again, no change. Okay, so which of the following answers matches our story? We're looking for constrict, constrict, no change, no change. And we can see constrict, constrict, no change, no change. I can say without a doubt that answer A is the right answer. I wish we had 6 minutes and 25 seconds to do this question. I would never get it wrong. But unfortunately, we have to do a lot faster and kind of do it quickly. So that's a sad part of USMLE. We just have to know it a lot more faster and be a lot more effective. Anyways, I hope you liked my interpretation of the pupillary light reflex. If you want to study more, please feel free to do so by going to page 462 for State 2012.